Today we are going to work with compound and continuous interest formulas. The first formula we are going to work with is compound interest. And this occurs when the interest accumulated for one period is added to the principal investment before you calculate the next period. So if you're asking me what the principal investment is, that is your initial investment. So again, compound occurs when your interest accumulated for one period is added to your original amount, and you do this before you calculate the interest for the next period, okay? So we are going to model this explanation by the formula A equals P times 1 plus R over N to the NT power. So what do these variables stand for? So the first one, A, is dependent on the principal, the rate, the N, and the T for time. It is calculated as the future value. What is the amount you will have after interest has been compounding? P is standing for the word principal, and this is the original amount you started with. R, it will always need to be expressed as a decimal. So if I give you a percentage, remember you will need to divide by 100, or as some students do, move that decimal places 2 places to the left. The letter N will stand for the number of times the interest is compounded for whatever period of time is said in your story problem. And I will talk about that a little bit more in a bit. And T will usually always be measured in years. So let's go back to that variable N. So again, the N is going to be the number of times your interest is compounded. So in every application problem, you are going to see the word compounding, and following the word compounding, you're going to see a word. So over here on the right, if you would follow along with me, if you see the word monthly, okay, in a year, there are 12 months in a year. Therefore, the N value is going to be 12. If you see, by the way, I'm going to give you, the more popular values that you tend to see in formulas. The N value for daily, again, how many days there are in a year. So 365. We actually do the word annually as well. And so here are just a few. Okay. So hopefully you're starting to see the trend of how this works. And I'm trying to think of another. Oh yeah, they love quarterly. Quarterly, your N value is going to be 4. And I believe the last one, semi-annually, that tends to be N equals 2. So these are the more popular ones that you will see. So you need to look out for those words so that you can establish what N value you will be substituting into your formula. So let's go ahead and jump right into some application problems that gives us some practice on how to work with this specific compounding interest formula. So here's our first problem. So Chloe invested $5,600 in an account paying an interest rate of 5.3% compounded daily. Assuming no deposits or withdrawals are made, how much money to the nearest $100 would be in the account after 7 years? So let us write out this formula here for a second. So we have A equals P times 1 plus R over N to the NT power. Okay, so let us see what is being given to us and what we need to solve for. So Chloe invested $5,600. So in this investing of $5,600, what they're giving us in this particular problem is the value of P. It is going to have an interest rate of 5.3%. Therefore, that's going to be our R, And we must not forget that we need to convert R into a decimal. So in this case, 0.053 is the value we're going to use. Compounded daily. So here is where you need to look out for that word compounding, because it's going to help you determine what your end value is. So in this case, our end value is going to be 365, since it's being compounded daily. There are 365 days in a year. The question is, assuming no deposits or withdrawals, how much money would be in account after 7 years? So when you ask how much money would be in the account after 7 years, that means you're looking at the final amount. Okay, so we are looking for A. So basically I should write find A. Find A. And then last but not least, they're giving us 7 years, and that's pretty obvious. They're giving us time. So let's substitute these values into this problem. We have established that we're looking for A, so I'm going to trace over this black A as a red because we're looking for A. And I'm going to substitute everything else. So A equals, my p-value was 5,600 times 1 plus 0.053 over 365 over 300, to the power of 365 times my 7 for years. Okay, so what are we going to do next? Well, notice that my A is already solved for, so all I need to do is plug in these numbers into the calculator and let the calculator do its own work. Okay, let it do all the heavy lifting. So A is already isolated. So let's go here and type away. So we have 5,600, and then open parentheses, 1 plus, I'm going to do alpha y equals to get that stack fraction, and it's 0.053, and then it's 365, close parentheses, and then I need to raise it to the power of 365 times the 7. And when I hit enter, we're going to end up with 8,115 point. If I round it to the nearest cents, it's going to be 0.21. So let's write that down, and then I will tell you what we need to do. So we had, as far as dollars, we had $8,115.21. But if you guys look here, they asked us to round to the nearest $100, not hundredth, okay? To the nearest $100. So what that means is we need to look for the hundreds place. Well, this is my ones place, this is my tens place, and this is my hundreds place. Therefore, I'm looking at the 1, okay, and I need to check and see, does the 1 need to stay a 1 or become a 2? It's going to stay a 1, because to the right of it is a number less than 1. So my final amount for A is going to be $8,100. Now, when you type it in Delta Math, you are just going to type the number 8,100. Okay, you don't have to worry about units. You're just typing what I just highlighted there in yellow. Okay, so let's move on. This is an example for solving for future value, where we're solving for A. Now let's see if we can solve for another variable in this given equation. So in here, this specific problem, you're going to see that we're solving for time. So Logan invested $390 in an account. So right now we know that we're going to use this value, okay, in an account paying an interest rate of 5.5%. So we know we're going to use this value. Compounded quarterly. Assuming no deposit or withdrawals, how long will it take? So that's the question that we're looking for. How long means find the time. And for the value of the account to reach $660. So here is what we have. So again, rewriting our problem here so we have a better visual. Okay, let's go down the line and substitute what we have. So starting with A. So by the way, we're looking for T. So let's, because how long is the question? And so let's make T red. So everything else that's black needs to have a number in it. Okay, so final amount. The final amount, we want it to reach $660 after our initial investment. So $660. We started off with $390. So that's our initial amount, our principal. 1 plus, my rate is going to be, so 5.5, move it 2 places to the left. We'll end up with 0.055. Whoops, my line's a little bit too long. 1 plus R over N. My N was quarterly, so that's a 4. And then a 4 times the T that I'm looking for. Okay, now here's what I want you guys to notice here. Notice T is an exponent. Okay. When you guys are solving for an exponent, you will need to, let me put here, actually, you will need to convert your exponential, let's call it a to the x equal b, okay, into a log equation. And the way we write log's equation for this particular a to the x equals b would be log base a of b equals x. Because if you notice, in rewriting the equation from exponential into log, you end up isolating the exponent that you're looking for, okay? So a to the x equals b, if you're solving for x, notice in this particular setup, our x is not isolated. But if I rewrote it in logarithmic form, notice now my x will be isolated. So let's go look at this problem. I need to solve for t. My t is right over here. If I can get that screen off. My t is right over there, and I need to isolate it. So what I need to do is make my equation look like an a to the x equals b. Well, if you guys look at this closely, if this is my exponent right here, okay, that's the x in my formula. 4t is going to be the x. My a value is going to be this piece right here. So that's going to be my a. I guess I can do this so you can visualize. This is going to be my x, a to the x. And then this over here looks like, this would look like my b. Okay, so this number right here, that's a problem. So I need to kind of get rid of it, but I can't exactly just erase it, okay? You can't just erase a number in math just because we want to get rid of it. We have to use some actual arithmetic or algebra. So let us get rid of it by, well, 390 is multiplying against 1 plus 0.0554 to the 4t power. So why not divide both sides by 390? So I'm going to divide both sides by 390. Notice these zeros are going to cancel out, and we're left with 66 over 39. Now, you can leave it as 66 over 39, or if you want to reduce it right off the bat, both of those are divisible by 3. So I'm going to write 22 over 13. And notice I'm leaving it in fraction form, okay? Don't worry that it's written in fraction form. So 0.055 over 4 to the 4 times t, where t is what we're looking for, okay? Now, I want you to notice that our equation is written now excuse me, in exponential form. So what we want to do is now rewrite it. Let us rewrite into log form. So I'm going to write log base A. Well, my A is that really, long, this here. Remember, that's my A. 1 plus 0.055 over 4. And then my B was I'm going to put parentheses here so you know it goes together. My B is going to be 22 over 13. Okay, equals my exponent, which is 4t. So all I did was rewrite it in exponential form. Okay, in logarithmic form, my bad. Okay, so again, to remind you, just in case you're not seeing it really well, this is my A to the x power equals B. And all I did is rewrite it in log form. So once I have this typed out, what am I going to do? I need to solve for t. Well, the t needs to be isolated, so I need to divide this side by 4 so that I can cancel to leave t by itself. And then whatever that answer is above, I'm going to divide it by 4, and that will give me my t. So get your calculator out, and let me show you how to type that problem out. So let me switch screens here and help you understand what we have here. So I need to remember these numbers. Okay, let's see here. So I'm going to clear this screen out, and I'm going to clear this history down here. Whoops, I meant yes. And let's do this. Okay, so if you would follow along with me, right over here on the far left, underneath your green button, if you are following along with a TI, you're going to press math. And then I'm going to want you to go over here to the up button, and I'm going to want you to press 2 or 3 times, depending on where you need to go. And notice I'm going to highlight what it says log base, and I'm going to hit enter on that. And when you hit enter, you're going to end up with this, with 2 spaces to be filled in, the base and then the number. Our base is that really long number of 1 plus 0.055 over 4. So I'm going to do alpha y equals, and then I'm going to write 0.055 over 4. And then it's going to be of the number, what was it again? I can't forget. Oh, 22 over 13. So let me do alpha y equals again. 22 over 13. Okay, so this is the numerator part, because then eventually, remember, we have to divide by 4. Okay, so there's my problem, and I'm going to hit enter, but I'm not done just yet because I need to divide by 4. And I'm going to hit enter. And there you go. There is our final answer, 9.6309 etc. But this particular problem asked us to round to the nearest 10th. So the nearest 10th is looking at this 6, and we look to the right of our 6, and that number is less than 5. So 9.6 is our final answer. So I'm going to come over here, and we have solved for t. So t equals 9.6 years. I'm going to box this in, and we're done. Again, up here in our story problem, notice they said 10th, so that's 1 decimal place. Okay, so we're halfway through. Let us move on to the next example. So let me scroll up here a bit. And we are going to work now with still compounding, okay? And this time it's compounding, but solving for the principal. So let me kind of make some space here, just in case I'm running out of space. Okay, so again, I'm going to go ahead and write the formula. So I have it here on standby. Okay. So I know our title says solve for principal, but let's read it and make sure we understand the wording so that we know in the future what to expect. Aubrey is going to invest in an account paying an interest of 1.5%. So I'm going to use some highlighting here, 1.5%. It is being compounded quarterly. How much would Aubrey need to invest to the nearest dollar? So we need to keep in mind what our rounding is for the value of the account to reach $5,600 in 16 years. Okay, so let us substitute. We know we need to find how much would she need to invest. That means we are looking for our p-value. So I'm going to make this red. Let me just rewrite it over in red. Red is the one we're looking for. Therefore, everything else in black needs to be substituted with a value. So A is the final amount. The final amount that we want to earn is going to be $5,600. We don't know what our p-value is, so we're leaving that in red. 1 plus the rate is going to be 0.015 over compounded quarterly, that's a 4, and then 4 times my t, in this case, is 16 years. Okay, so you're going to see that we're looking to solve for p. Now p is multiplying by this big number right here, and we need it to be isolated. So what I need to do then is get rid of that number, that black number to the right of t. Since these two values are multiplying, I can put a little dot there to show that it's multiplying. I need to divide both sides by that outrageously big number right there. Okay, so I'm going to rewrite 1 plus 0.015 over 4. And I'm going to go ahead and say 4 times 16 is 64. I'm going to put 64 there. In order for this to cancel, see, I'm doing that because I want to get rid of that and isolate p. But whatever I do on one side, I must, of course, do it on this side. So notice that there's no work here to be done other than typing it into the calculator. I am going to assume you know how to do that since we've practiced a couple. When you do this, your p-value is going to be monetarily, if we rounded it to the nearest cents again, it would be 4407.09 cents, 4,407.09 cents. But they asked us to highlight, I'm going to highlight it. They asked us to solve to the nearest dollar, okay? So since they're asking us to solve to the nearest dollar, I need to look to the ones place, okay? And so this is going to end up being final answer of 440. It's going to be a 7 because the number to the right of 7 is not larger than a 5. And there's my answer for principal. So you have to at least begin with an investment of 4407 in order to accrue interest after 16 years to have a final amount of $5,600. Okay? All right. So hopefully you are feeling pretty comfortable as we arrive to the last problem. So now let's go look at a different type of compounding problem. And this problem is this formula is called a compounding continuously problem. So what does it mean to compound continuously? Think about it. Based on what we talked about earlier, what do you think compounding continuously means? Okay, so recall. So we were talking about when something's compounded You are talking about your interest accumulating for one period, and then you add it to the principal investment before you calculate interest again for the next period and add it again, and so forth. But sometimes that's not going to happen. Sometimes you're going to have what's called compounding continuously. And in this case, your annual interest rate, using the time in years for the investment, this time your money or whatever your initial principal amount that you invested is going to accrue continuously versus every single period. Okay, so when that happens, you're going to see compounded, and you're going to see the word continuously. You won't see the words like you saw way up here at the top. If I scroll down again, guess it's way down. Okay, so way over here. So monthly, daily, annually, weekly, quarterly, these are giving you specific time periods, okay? And each period, according to the way it's set up, that's where your interest is being accrued. But if it's continuously, a formula is not going to have an end value. It is going to look like this boxed formula that I am bringing you back to. So copy this one down now. This is the continuously compounded interest formula. Notice though that your A and your P and your E, I mean not your E, sorry, your R and your T all have the same meaning, okay? They have the same meaning. So let us look at an example. This is our last example of how compounded continuously works. And you will notice that the application is pretty much the same. So I'm going to write this problem down right now. So as far as the formula goes, so A equals P times E to the R times T. Okay, so this is our compounding continuously problem. So I know I'm going to use compounding continuously problem because here it's not giving me monthly or daily or weekly. It's giving me the word continuously. And as soon as they give me that word, I know I'm going to use this second formula that I'm introducing you to. So using a different highlighter here, let's use green. We are investing in $1,400. We're going to leave it in the account for 8 years. And we want to end up with a final amount of $2,200. And what else? So right now they're asking us is find the interest rate. What interest rate do I need to have in order to achieve getting my money to go from $1,400 to $2,200? So let's substitute. Since I'm looking for interest rate, let's use green here. For R, we're going to use R is what we're looking for. Okay, so R is our unknown. Our A is our final amount. Our final amount is $2,200. Our initial principal amount of investment was $1,400 times E. Okay, so it's $1,400. It's like an invisible, whoops, my thing shifted. It's like an invisible times button here, times E to the R, which is what we're looking for. So let me put it in green. Don't even know my colors. Times T, which is 8. Okay. So notice again. Okay. Notice again. Look at the variable I'm looking for. And so there's an alert. Okay. It is an exponent. And you guys know when we have to isolate an exponent, you have to rewrite it. You have to rewrite the equation. Okay? Rewrite into log because that's the only way to isolate the variable. Okay? So again, we want to go from a to the x power equals b, which is an exponential function. And we want to convert it into log base a of b equals x to be able to isolate our exponent. Right now, let's analyze this and determine what's our A, our X, and our B. So right now our A should be the number that's with my exponent, X, right? So therefore, right here, this E, my irrational number E, that's my A. This right here, R times 8, is my X. And this right here is my B. So this here needs to get rid of. My 1400 needs to go away. So just like a problem or two ago, we need to get rid of 1400, not by erasing it. We are going to divide this side by 1400. And I'm going to divide this side. I'm going to write over the B here, but you know what I'm doing. Divide this side by 1400. So in so doing, by the way, here these two zeros and these two zeros will cancel. 22 over 14, they're both even numbers and they're both divisible by 2. So let's make that 11 over 7. And notice that the 1400's canceled. Now I have an E. R times 8 is 8R. I'm going to put 8R because it's just prettier that way. So now I have an exponential function. So notice I have an A to the X equals B format. So let us convert. Okay, now I can convert it into log form because I have it in exponential form. So convert it into log form. So I'm going to write log of my base. Now my base is base E of B. The B value is what it was equal to, which is 11 over 7. And then I have to equal it to my exponent, which is 8 times R. Okay. Now, log base E, hopefully you remember this. Okay, don't forget that log base B, log base E is just natural log. So instead of writing log base E, anytime you have log base E, the irrational number, just write it as ln. Okay. Now, I need to get R by itself. So I'm going to divide by 8. I'm going to divide by 8. So far, everybody okay? Let me bring this formula down. Oops, I didn't want to bring this down though. Is there a way to leave that there? There we go. And how can I get all this together? Let's see. Okay, that's not working. All right, stand by here as I try to get this to move up. There we go. Thank you for waiting. Okay, so I need to type this in my calculator, and let's get that 8 to cancel. So I have the natural log of 11/7 divided by 8, and I need to get that answer. Okay, and we're solving for the rate. So let's go to my calculator. And again, I'm going to clear out this screen here and here so that you can make sure you understand where we're typing. So moving my cursor around right here, right on by next to 7 and 4, the numbers, you're going to see a log button, LOG, and an LN button, LN. Here's your natural log button. So you're going to press LN. And we were doing ln was 11 over 7 was the quantity. So I'm going to type 11, and then I'm going to arrow down and type 7, close parentheses, and then that whole thing was going to be divided by 8. So I'm going to put divided by 8. And I'm going to get this decimal value, 0.0564981, blah, 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 okay? Now, because they told us, I'm going to switch screens here a second, they told us that they wanted us to find the interest rate to the nearest 1/10 of a percent. Okay, so I'm going to highlight here so you know where I'm reading. They said, what interest rate to the nearest 1/10 of a percent? Notice they're saying percent. Okay, the answer I just got is a rate. It's a rate, 0.056498. That's a rate. So to make it into a percent, I need to multiply my answer by 100. I'm going to hit enter. And now this is the answer that you are going to round. And they wanted us to round to the nearest 1/10. The 10th place is the 6. So I look to the right, and my 6 is lower, my number is lower than 5, so my 5.6 is retained. So going back to our paperwork, my R, wrong button, my R is going to be approximately equal to 5.6%. So make sure you convert it into a percent first, and then once you have converted it into a percent, then do the rounding last, okay? Don't round and then convert to a percent. Okay, now you may be asking, wait, this log E piece, when you rewrote it as ln, it kind of confuses me. It's just notation. So if you are like, I don't think I'll remember that log E means natural log. What I want you to understand is that you can still, I want to show you how the answer still stays the same. If you want to use the math button and do math, and you arrow up to log base and hit enter, and you write, you keep the log instead of ln, and you want to put here the value of E. Well, the value of E is right here above the division symbol. It's in blue. Do you see it? So since it's in blue, you have to hit second and then the division button, and notice there's your E. And then I'm going to arrow over, and the fraction was 11/7. So I'm going to do alpha y equals, so I can type 11 over 7. 11 over 7. And after all of that, we still had to divide by 8. So I need to put divide by 8. So I want you to notice how this line up here, ln 11/7 divided by 8, is the same thing as log base E 11/7 divided by 8. Because when I hit enter, I get the same number 2 lines above. I still need to multiply by 100, and I will round. So the process answer is still the same. Sorry, the answer is still the same. The process typing is slightly different. Okay. This last problem right here, I'm actually going to let you guys work on it on your own for your own extra practice. I am going to tell you what the final answer is, and if you want the work, you can just log on to Google Classroom to find the work behind this problem, but I challenge you to do it on your own. And so here's that problem, and I'm going to tell you that the final answer rounded to the nearest dollar, he said, is going to be the amount of $114 more. Okay, so I challenge you to work this problem out on your own and see if you can get this answer. Thank you so much for watching and listening to the last lesson of our Unit 10.